Welcome back, everybody. We're still factoring here. Factoring is a huge part of Algebra 2. So we're spending quite a bit of time with these different types of polynomials and learning how to factor them and put them in their factored form. Remember the last time we talked about how to factor perfect square trinomials and difference of squares. So if you forget what that's all about, you may want to go back and take a look at your lesson notes again. This is what they look like. Remember, here they are, PSTs and difference of squares. We're going to continue with this idea of these two, but we're going to look at a few other types of polynomials where PSTs and difference of squares come into play, okay? So I want to pick it up right here. Sometimes when factoring a polynomial that has four terms, remember before we talked about 2 by 2 grouping as being our default. But after the 2 by 2 grouping, we may be able to factor further than just that single 2 by 2 process. All right, and we'll need to pay close attention to the grouping of our terms. So let's take a look, for example, at this polynomial. It does have four terms, and by default, remember, the first thing we do is see if there's a greatest common factor of all the terms. And then we look and we say, oh, there's no GCF in this four-term polynomial, so we're going to go ahead and try 2 by 2 grouping. Now look at what I did here. Notice that the minus sign before the 4x, I included in that second set, okay? And that's going to be important because I think it adds clarity to the way that we factor it. So remember, 2 by 2 grouping, we find the GCF of each group. And if I look at the first group, the GCF is x squared. And if I factor in x squared from the first group, I'm left with x plus 3. Now in the second grouping, the leading coefficient is negative. So I do want to factor out a negative, and the GCF is going to be, in this case, negative 4. And if I factor out a negative 4, I get x plus 3 as my leftovers. Why did I get plus 3? Well, because negative 12 divided by the GCF of negative 4 will give me positive 3. And the GCF of the entire four-term polynomial is x plus 3, so that gets its own factor. And the leftovers outside, x squared minus 4, get their own factor. But look closely. Aha. This binomial is a difference of squares, so we do have to take it another step further and factor that difference of squares down one more time. All right, the x plus 3 doesn't change. Do you remember how to factor a difference of squares? Yeah, you take the square. What's being squared for the first term? What's being squared for the second term? And they get opposite signs in between. So x plus 2 times x minus 2, which means this four-term polynomial that we started with in its fully factored form is x plus 3 times x plus 2 times x minus 2. So you can see we kind of have this difference of squares embedded inside this four-term polynomial. And you wouldn't know it by looking at it, but it actually turns out that the factoring of this polynomial is going to require us to do a couple steps. All right, with that in mind, let's take a look at something a little bit different, okay? Now, we know that generally speaking, when we have a four-term polynomial, what we want to do is we want to first see if there's a GCF, but then do 2 by 2 grouping. If we look closely with this polynomial and we think about what would happen if we did 2 by 2 grouping, we realize suddenly, let's see, x plus 6. Then we realize, you know what? We're not going to get a common factor from the 2 by 2 grouping. So 2 by 2 grouping is not the technique that we want to use here. But if we just take a second and examine this a little bit closer, we realize that the first three terms in this four-term polynomial is a PST. Yeah? So if we're going to factor this polynomial, maybe what we want to try is 3 by 1 grouping. So 3 by 1, 3 terms by 1 terms. And if we factor this PST, whenever we factor a PST, we always get a binomial squared, right? So we get something squared. And in this case, if we factored x squared plus 6x plus 9, we get x plus 3 squared minus y squared. Ooh, now, one observation here. we have something squared minus something squared. Does that sound familiar? It's the difference of squares. So this, what we have written here, the quantity x plus 3 squared minus y squared, is a difference of squares that we can factor even further. Now, a few classes ago, or a few weeks ago at this point, I suppose, I taught you something called the U substitution, right? Do you remember that? U substitution? Basically, it said that I can use any other variable, and we choose u, to replace a polynomial with more than one term to make it a little bit simpler. So if I let u, for example, equal x plus 3, then this polynomial can be written as u squared minus y squared. And it might seem a little bit more like a difference of squares now, right? And so how would we factor this? This would be u plus y times u minus y. U minus y. And finally, since u is x plus 3, we can say x plus 3 plus y is our first factor, and x plus 3 minus y is our second factor. So take a look at what happened here. The first three terms was a PST. And so we factored this by 3 by 1 grouping. And the PST factored was x plus 3 squared, which turned our polynomial into a difference of squares. And then, now you can use the U substitution if you want. You don't have to, if you can just recognize this as a difference of squares from the beginning, something being squared minus something being squared. You could just jump to the very last step, but U substitution sort of makes it simpler, and then we can go back and replace the U with whatever it's representing. Now, let's take a look at another example of a four-term